Imagine waking up, grabbing your coffee, and opening your daily tech news to read that a new artificial intelligence model has just successfully matched human reasoning capabilities.
Right, just a casual Tuesday morning headline.
Exactly. And then you scroll down maybe 1 inch on your screen, only to see that half your country is, well, literally choking on wildfire smoke.
While the other half is just boiling in 112-degree heat.
Yeah. Today, we are looking at a single, incredibly surreal snapshot in time, August 18th, 2026. Welcome to today's deep dive.
We are jumping directly into a specific issue of the Daily Tech Reader that you, the listener, shared with us. And it creates this fascinating collision of two completely different realities.
It really does.
Because on one hand, you have massive headlines about exponential, frictionless digital expansion. But then, running right alongside it, you have a blunt, raw data dump of the National Weather Service's selected cities summary for that exact same day in August.
And we are going to dissect that weather data today, because treating it like a standard forecast, that misses the point entirely.
Oh, absolutely. It's so much more than that.
When you force yourself to zoom out, when you freeze a landmass as massive as the United States at one single moment, you aren't just looking at whether you need to pack an umbrella.
Right. You are looking at a living, chaotic, thermodynamic system in motion.
Yes. And we want to find the hidden physical narratives inside these numbers. Like, what does this snapshot reveal about the extreme environments people were navigating on this specific Tuesday in 2026?
Well, the extremes are definitely the place to start.
For sure. Let's start with the most aggressive data point leaping right off the page. The sheer, brutal extreme of the heat. Because looking at the desert Southwest in Texas, these numbers sound physically dangerous to endure.
They do. And the source data from this day is staggering. Plus, dangerous is the correct biological term here. We're looking at a massive swath of the country just baking under intense triple digits.
Wichita Falls, Texas is sitting at 108 degrees.
Yeah, and Dallas is right behind it at 106.
And as you trace the map westward, the heat just compounds, right? Phoenix is at 111 degrees, and Yuma, Arizona hits an astonishing 112 degrees.
Which is just punishing.
Okay, let's unpack this, though, because I have to challenge the way this data is categorized.
What do you mean?
Well, if you look closely at the summary, the National Weather Service presents a really bizarre numerical puzzle. Wichita Falls is 108, Dallas is 106, and the report simply categorizes their weather condition as sunny.
Sussy.
Right. It almost sounds pleasant, or at least, beautifully mundane. But then you look at Phoenix at 111, Tucson at 104, or Yuma at 112, and they get this intense, specific, all caps tag VRY height hot. Very hot.
Which seems entirely logical on the surface, considering those Arizona cities are crossing the 100-degree mark so aggressively.
Sure, it makes sense at first glance.
You might naturally assume VRY height hot is just a static, universal temperature threshold. Hit 110, get the warning.
But it's not a static threshold. That is the puzzle here. If you pan over to Florida and South Carolina on this exact same day, Miami Beach is 98 degrees, West Palm Beach is 97.
And Columbia, South Carolina is 98.
Exactly. And all three of those cities also trigger that severe VRYH hot T label.
Right.
So as a listener trying to parse this, you have to wonder, why does a 98-degree day in Miami get the exact same severe data warning as a 112-degree day in Yuma, while a 106-degree day in Dallas is just cheerfully listed as sunny?
That's a great question.
It implies there is a massive hidden variable manipulating the data.
What's fascinating here is how the NWS Selected Cities Summary communicates danger. It isn't just giving us raw temperatures. The hidden variable is atmospheric moisture.
The humidity.
Exactly. And it completely reframes how we should read this entire summary. The National Weather Service isn't just feeding us raw thermodynamics, they are actively calculating and communicating biological threat. That VRY shed tag isn't a strict temperature cutoff. It's an algorithmic recognition of the limits of human endurance.
Meaning the algorithm is factoring in the heat index.
Yes, precisely.
Because standing in a dry, roaring oven in Texas is a profoundly different physiological experience than, say, standing in a boiling pot of water in Florida.
Let's break down the biological mechanism behind that for a second. Your body is essentially a furnace that constantly needs to vent heat.
Right.
And it cools itself primarily through the evaporation of sweat. So in Dallas, at 106 degrees, the air is likely dry enough that your sweat can rapidly evaporate off your skin.
So you are undeniably baking in the sun, But your biological cooling system is still functional. The heat is being carried away.
Right. The machine is working as intended.
Okay, that makes sense.
But in Miami Beach, at 98 degrees, the regional humidity is likely so overwhelmingly high that the ambient air is already fully saturated with moisture.
Like it physically cannot hold any more water.
Exactly. So your sweat doesn't evaporate, it just sits there on your skin.
Oh, wow.
The primary cooling mechanism completely fails, and your internal core temperature begins to rise at a terrifying rate.
Yeah.
By tagging both the 112-degree desert of Yuma and the 98-degree coast of Miami as VRY HESA, the data synthesizes raw heat and humidity to tell one specific story.
Which is that in both of these environments, human survival is actively compromised.
Exactly.
It really makes you read the word sunny next to Dallas at 106 in a totally different, almost menacing way.
Yeah, it isn't an optimistic forecast at all.
No. It's bluntly stating that there are absolutely no clouds to block the oven's heating element. It's an unfiltered solar barrage.
That's a very vivid way to put it.
And that intense baking heat in the Southwest doesn't just stay isolated in a vacuum. It interacts with the rest of the continent, which brings us to the eastern half of the country on August 18.
Right, because while the West is stagnating under clear skies, the East is showing us exactly what happens when different atmospheric boundaries violently collide.
The contrast across the map is immense. If you trace a line down through the Midwest, from Green Bay and Milwaukee down through Chicago, Madison, Lincoln, Omaha, and Des Moines.
That entire geographic corridor is flashing with thunderstorms.
Yeah, it is a solid continuous wall of organized severe weather blanketing the region.
But the wild part is the temperature data attached to those storms.
Right. Despite the turbulent weather, the temperature across that entire Midwestern block is uniformly locked right around 80 to 83 degrees. Chicago is 81, Milwaukee is 82, Des Moines is 79.
A very tight cluster.
Very tight. Then you pan the camera down to the southeast, Savannah, Charleston, Montgomery. They are also getting hammered by thunderstorms, but their temperatures are punishing.
Completely different story down there.
Charleston is 101 degrees with thunderstorms. Savannah is 100 degrees. Montgomery is a 99.
If we connect this to the bigger picture, it illustrates how two entirely different meteorological phenomena get deceptively labeled with the exact same word.
Just thunderstorms.
Right. The thunderstorms in the Midwest represent what meteorologists call a synoptic scale event.
Synoptic scale. Okay, what does that mean in plain English?
It just refers to a massive continent-wide weather system rather than a localized pop-up storm. In this Midwest data, a sweeping cold front is actively pushing through the region.
Oh, I see.
And it's violently lifting the warmer, stagnant air out of the way, which creates that massive line of storms.
So the storms in Chicago are essentially the turbulent front lines of a war between two different climates fighting for territory.
And importantly, that fight brings immediate relief. The heavy rain and the dense, cooler air mass dragging behind that front are capping the high temperatures firmly in the high 70s and low 80s.
So the thunderstorms in the Midwest are the physical mechanism of cooling.
Exactly.
It's like a giant, temperate, atmospheric car wash. It's loud, it's turbulent, but you come out the other side rinsed off and cooled down.
That's a great analogy.
But what is happening in the Southeast? Because, I mean, an 80-degree thunderstorm in Chicago cannot functionally be the same physical experience as a 101-degree thunderstorm in Charleston.
Not even close.
The data just says thunderstorms for both, but the reality on the ground has to be wildly different.
The reality is completely inverted. The Southeast on August 18th is trapped under a heat dome.
A heat dome?
Yeah, a massive high-pressure system that traps blistering heat near the ground like a heavy lid on a boiling pot. The thunderstorms down there aren't caused by a refreshing cooling front sweeping through.
So what causes them?
They are driven by intense localized atmospheric convection. The heat and humidity build up so aggressively under that high-pressure lid that the air essentially boils over.
Oh, wow.
The moisture rises rapidly, condenses into dark clouds, and collapses right back down as a pop-up thunderstorm.
So the rain in Charleston isn't cooling the city down at all. It's just the atmosphere sweating.
That is a perfect way to visualize the mechanism. Those storms provide absolutely zero relief from the 100-degree extremes. The rain hits the scorching pavement, instantly flashes back into steam, and spikes the humidity even higher.
That sounds miserable.
It really is. For you, the listener, if you're standing in Chicago on this day, the thunderstorm means a welcome break in the heat. If you're standing in Charleston, the thunderstorm just means you are going to feel like you are trying to breathe underwater for the rest of the afternoon.
And meanwhile, acting as a bizarre middle ground, you have the Northeast and Mid-Atlantic, New York City, Newark, Providence, they're sitting relatively comfortably in the mid-80s with mostly cloudy skies and mild showers.
Boston is sitting at a pleasant 78.
Right. It's as if the entire eastern seaboard is acting like a geographic buffer zone, insulated from the violent fronts and the crushing heat domes happening just south and west of them.
The eastern half of the map tells a story of large, sweeping regional narratives, massive storm walls and expansive high-pressure domes. But when we pan our data map over to the Pacific Coast and the Mountain West, that broad narrative completely fractures.
Yeah, it really does.
We stop seeing unified regional systems and start seeing terrain-driven chaos.
Geography completely dictates reality out west. You look at California, and the microclimates are incredibly stark.
Very true.
San Francisco is sitting under mostly cloudy skies at a very mild 74 degrees. But take a short drive inland, crossing away from the protective water, and Fresno is sunny and baking at 98 degrees.
You see the exact same coastal versus inland split in the Pacific Northwest, too.
Oh, yeah. Seattle's mostly cloudy at 78, shielded by the coastal marine layer. But cross the Cascade Mountains over to Yakima, Washington, and suddenly it's sunny and 94 degrees.
And then you drop into the Mountain West, and the numbers just lose all sense of regional uniformity.
It's all over the place.
Pueblo, Colorado is a sunny 99 degrees. Just a short drive north, Denver is getting hit with thunderstorms at 91 degrees.
And then go a bit further north to Casper, Wyoming, and the city is experiencing light showers at a cool 82 degrees.
The mountain ranges disrupt the atmosphere so thoroughly that the weather becomes entirely localized.
Here's where it gets really interesting, though.
Yeah.
Because amidst all this regional mountain chaos and coastal dividing lines, there is one specific data point on this list that feels deeply unsettling.
I think I know which one you're talking about.
You scan down the Pacific Northwest cities, Seattle, Portland, Eugene, and then you hit Boise, Idaho, and Spokane, Washington. Boise is 94 degrees, Spokane is 90.
Right.
But their weather condition isn't listed as sunny, it isn't cloudy, it isn't showers. The baseline weather condition for both of those cities is just one word:
smoky. It is incredibly jarring to encounter that word in the middle of a standard meteorological summary.
It really is. And I think we need to interrogate the implications of this. We are so heavily conditioned to read a standard, almost comforting vocabulary of weather words that describe the natural behavior of water vapor, atmospheric pressure, and sunlight.
Natural systems.
Right. And then suddenly, a physical byproduct of widespread combustion, a thick, localized pollutant, is slotted into the data as a baseline atmospheric state. It treats a massive environmental crisis like it's just a passing cloud cover.
This raises an important question, because that categorization choice by the National Weather Service reveals a profound shift in how we are forced to interact with our environment.
How so?
Well, the summary isn't treating smoke here as a temporary anomaly or, a breaking news alert to be broadcast on the bottom ticker of a news screen. By giving it equal footing with standard terms like cloudy or sunny, the data is quietly acknowledging a new permanence.
It's the normalization of the extreme that is so striking.
Yes, exactly.
If you are living in Boise or Spokane on August 18, seeing smoke on your morning weather app isn't just an interesting piece of meteorological trivia. It dictates your entire day.
It tells you whether it's safe to let your kids play outside.
Right. Or if you need to run your air purifiers on max, or if you can even see the mountains from your window. It's a localized emergency flattened into a standard data point.
The particulate matter in the air has become so dense and so pervasive over those cities that it is the primary defining characteristic of the sky.
That's a wild thought.
It blocks solar radiation, it alters the localized temperature, and it fundamentally changes human behavior just as much, if not more, than a torrential downpour.
Yeah, that makes sense.
When our core data classification systems adapt to include things like smoke or VRY high hot as standard everyday acronyms, it serves as a mirror reflecting a much harsher physical reality that people are just expected to navigate.
Which perfectly brings us back to the source material itself.
Right, the daily tech reader.
We have to talk about exactly where you, the listener, found this data, because this weather report wasn't pulled from a farmer's almanac or a dedicated meteorology journal. You pulled this from a publication intensely focused on cutting-edge technology and artificial intelligence.
The juxtaposition is what makes this specific snapshot so culturally compelling. On the exact same platform where you are tracking these visceral physical constraints, sweating through 112-degree heat in Yuma, dodging 101-degree pop-up storms in Charleston, breathing in dense smoke in Spokane,
Yeah.
You are simultaneously reading about the rapid, almost frictionless expansion of the digital world.
So what does this all mean? Let's look at the actual tech headlines flanking this weather report in the summer of 2026.
There were some massive developments.
Massive. In July, OpenAI launches GPT 5.6 alongside something called ChatGPT Work, which is billed as a unified AI workspace, taking aim at completely overhauling how enterprise knowledge workers operate.
Right, a huge leap forward in enterprise tech.
But around the exact same time, the New York Times is actively seeking sanctions against OpenAI in court, fighting a massive legal battle over withheld evidence regarding the training data that powers these models.
We are seeing these huge clashes over the very foundation of the digital corpus. And just weeks before this August 18 weather snapshot, a Chinese AI model called Moonshot Kimi K3 reportedly matches U.S. frontier models.
Yeah, that was a huge deal.
It starts dominating the top 10 rankings on OpenRouter, which is a major platform where developers access, route, and benchmark different AI models against each other.
So put yourself in the shoes of someone scrolling this site over their morning coffee. You are absorbing news about AI models leapfrogging each other, supposedly unifying global enterprise, and matching human reasoning capabilities.
The pace of it all is dizzying.
It is. You are reading about multi-billion-dollar legal wars over the entire digital corpus of human knowledge. It's a world of boundless, aggressive digital potential. But then right below it, literally sharing the same pixels on your screen, is the blunt reminder that half your physical country is boiling, the Midwest is trapped in a wall of water, and entire cities can't see the sun because of wildfire smoke.
It synthesizes the dual reality of our current era. We are building incredibly advanced, seemingly transcendent digital tools.
Hoping to transcend the physical, really.
Exactly. The digital world operates on the promise of escaping physical limits.
Yeah.
But the weather data proves we are still entirely, inescapably tethered to our biology and our geography.
Because, I mean, the cloud isn't actually in the sky. It's in a server farm.
That is the core physical contradiction. The AI might be dominating OpenRouter virtually, but the massive, sprawling data centers required to run those billions of parameters require astonishing amounts of electricity and water for cooling.
Oh, right.
And those physical data centers are sitting in a world where it might be 108 degrees in Texas, heavily straining the power grid, or 111 degrees in Phoenix.
The infrastructure is deeply physical.
Very physical. And the knowledge workers integrating GPT 5.6 into their daily workflow are still human beings who cannot simply prompt their way out of 98-degree heat and 100% humidity in Miami.
You can build a unified AI workspace, but you cannot optimize an algorithm to make the smoke in Boise disappear.
You really can't.
The digital world is advancing at absolute light speed, but our physical constraints remain stubbornly absolute. This single page from the Daily Tech Reader encapsulates that tension perfectly. We are reaching for the digital stratosphere, but our feet are planted firmly on very hot, very turbulent ground.
By taking the time to zoom out from our hyper-localized daily routines, like just checking for an umbrella, we get to see the immense mechanics of that physical world working in real time.
It's eye-opening.
This snapshot provides the actual pulse of an entire continent on one specific day.
From the algorithmic VRYH-hot warnings bridging the humid coast of Florida to the arid deserts of Arizona, to that massive, cooling synoptic storm wall carving up the Midwest.
And the stark microclimates of California.
Right. And the heavy smoke settling over the Pacific Northwest. The geographic tapestry hidden inside just one single day of numbers is astounding.
It gives you a profound sense of scale, and it challenges how we document our own history.
It really does. Which leaves you with something fascinating to mull over as we wrap up this deep dive. When we look back at historical data from a century ago, we usually focus on the big, bold-faced events,
Stock market crashes, major treaties.
Who won an election, yeah. But imagine a historian 100 years from now digging through digital archives and finding this exact page from August 18th, 2026.
That would be quite a find.
They are going to have to look at the juxtaposed headlines and ask themselves, which half of this page tells the more accurate story of what it actually felt like to be alive? Was it the launch of GPT 5.6 and the promise of a limitless unified AI workspace? Or was it the fact that millions of people were navigating 112-degree heat while smoke quietly became just another everyday word for the sky?